Hello, this is Math 2231 coming to you from the College of DuPage during the summer of 2020, and this is the conclusion of the lecture entitled Computing Indefinite Integrals and Solving Initial Value Problems. When I left you in the last video, you were working on solving these problems. I hope you finished them, but in case you were distracted, you got another chance. You know what to do. Let's see how you did. Well, we're going to be doing this term by term. I see three terms. I'm going to jerk the constants through the terms, through the integrals, and I'm going to do it term by term. So the integral of e to the x is e to the x, so it's 3e to the x for that one. I pull the 5 out, and I'm integrating the cosine of x, and the integral of the cosine of x is the sine of x. I pull the minus 10 out. I'm integrating the secant squared of x, and that is going to be the tangent of x, and I have a constant of integration. Please make sure you follow all of these steps. Here's the next one. Again, we're going to do it term by term. So I can jerk the 2 out here, and I will be integrating the secant w times the tangent of w with respect to w, and that's going to be the 2 secant w. Now here, what I'm going to do is I'm going to pull the 1/6 out, and now I'm taking 1/6, integrating it 1 over w dw, and that's going to be the natural logarithm of w, and then of course there's a c. Now this c is the sum of both of those c's, but since it's a constant, I can just do it that way, and c is as good as c1 plus c2. Here we got 1, 2, 3 terms. I'm going to pull the 23 out of here, so I'm integrating with respect to y, 1 over y squared plus 1. That's going to be the arctangent of y, so it's 23 arctangent of y. Here the 6 is pulled out. I'm integrating the cosecant of y, cotangent of y with respect to y, and that is going to give me the cosecant of y, a minus cosecant of y. And so there's the minus sign that I was looking for. And here I pull the 9 out. I have 1 over y again, so that's going to be 9 times the natural logarithm of the absolute value of y. And then I lump all the constants together into one big constant. Here I have 1, 2, 3 terms. I'm integrating with respect to x. I pull the 3 out of the integral, and that is 3 times the arcsine of x plus the 6 comes out, and I'm integrating the sign. Now the antiderivative of the sign, or the integral of the indefinite integral of the sign, is minus cosine, so the sign changed here. Plus the 10 pulled out, and the antiderivative of the indefinite integral of the sinh of x is the cosh of x. And there is my constant, where I combine all of the constants that I've had thus far. This was a little bit more involved. I have to do what we did before. I'm going to be dividing the sine squared into each of those terms. Now when I take sine squared into this, that is 7 over sine squared theta, which I know is the cosecant squared of theta. Again, we have to know our trig. When I divide sine squared into this, I just get minus 6, and the whole thing is d theta. So this is what I have. So I do it term by term, and the antiderivative of the cosecant squared is minus the cotangent of theta. And this is just going to be minus 6 theta, and there's my constant of integration, all combined into one big constant. Let's look at another problem now that we've completed those. This is integrating this expression. You know what to do. Let's see how you did. We're going to have to use a trig identity in order to do this. This is the problem that we had, but we're going to use the sine of 2t. Yes, you do have to know these identities. And if the sine of 2t is 2 times the sine of t cosine t, then if I divide both sides by 2, I get the sine of t times the cosine of t is equal to 1/2 the sine of 2t. Now, down here, I really don't have t. I have, perhaps we call it z, is t over 2, but the same thing holds, the same relation holds, and this is 2 times t over 2. So we have this relationship, so we can do this substitution. Pull the 1/2 out. Now we're integrating the sine of t dt, which is the negative cosine of t. So the answer at the end of this problem is minus 1/2 cosine of t plus a constant. This is a different kind of problem, and actually there are two problems here. The first one, in both of them we want to find out what is f of x. But here I tell you that f prime of x is this expression. And moreover, I tell you some additional information that f at 0 is equal to 15. Here I tell you the second derivative is equal to this expression. But I tell you two pieces of information. F of 1 is minus 5 over 4, and f of 4 is 404. Two problems, you know what to do. Oh, let's see how you, well, before we see how you do, problems of this kind are sometimes called initial value problems, IVPs, or boundary value problems. I should have put another quote there, I did not. So you have two problems to do, you know what to do. Let's see how you did. Let's see how you did. Okay, so here, first thing that we're going to do is we're going to integrate f prime. So we integrate this, and what I will find that f of x is equal to the indefinite integral of that. I will do each term. So this is going to be the indefinite integral of 4x cubed with respect to x is x to the fourth. The integral with respect to x of minus 9 is minus 9x. The integral of this is going to be minus 2 cosine of x, because the sine, the antiderivative, the indefinite integral of the sine of x is going to be the negative cosine of x. And here I just get 7e to the x, and there's my constant of integration. But now I can use this information to figure out what c is. So I'm going to plug this in. So I'm going to say 15 is f of 0. I put 0 everywhere. Now I realize each of the 0 is 1, so that's going to be 7. Cosine of 0 is 1. And so I get this. So 15 is equal to 5 plus c. That means c is 10. That means my answer is this one. And so you see, I know what the constant is for this problem. In the second one, I actually have to do this twice. So the first thing I'm going to do is I am going to integrate this, but when I integrate the second derivative, I get the first derivative. I put these in, and so what I get here is going to be 15 just sits there, but now I add 1 to the exponent, that is x to the 3/2. Dividing by 3/2. Dividing by 3/2 is the same thing as multiplying by 2/3. I go to this one, there's a 5 that just sits there, but I add 1 to the exponent and divide by the new exponent. I get this, and this is 6x, and that is my constant. But now I'm going to use this information to find out what my, well, I'm going to use that information in a bit to find out what my constant is. But I'm just, first of all, going to integrate again. Now I have a constant here, so I have that constant times x plus d. And when I have the 10 just sit there, I add 1 to the exponent, and I do these calculations. You should verify this, but this is what I get when I integrate this yet again. Cx plus d at the end. But now I'm going to look at these two conditions. So when I put 1 in for x, I get minus 5 over 4 is equal to, and I do the calculation and I get this. And when I put 4 in, I get 404 is equal to this. So you see I have two equations. There's one, and there's a second. Two equations in, two unknowns. I solved them. You know how to do this. We covered that in our review. And so this is going to be c is minus 13 over 2, and d is minus 2. So I go back and I plug c and d into here, and there is my final answer. Neat, huh? And in closing, or almost closing, we're going to talk about rectilinear motion also, because remember, we learned that if you had position, the first derivative of position with respect to time was velocity, and the next derivative of velocity with respect to time is called acceleration. So you see, we can run this backwards using antiderivatives. So when you're having rectilinear motion, that is up and down motion, the height of a projectile, the only acceleration in town is due to gravity. So h double prime, that derivative with respect to t is g. The velocity then is the indefinite integral of acceleration. So velocity is going to be the integral, and when we integrate this, we get g times t plus c. But if I plug in 0, that is my initial velocity. So that means the velocity is equal to gt plus v0. But position is the indefinite integral of that. So I integrate again. v0 is a constant and g is a constant. So I get 1/2 g t squared plus v0t plus c. But c has to be the height when time is 0, so that's my initial height. So this is the formula that you learned in high school. H of t is equal to 1/2 gt squared plus v0t plus h0. That might have been the coolest thing we've done so far in this course. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. God bless you all.